Welcome to the Provider IBM Cloud introduction and deep dive. My name is Sahdev Zala. I am here with my co-speakers, Brad Topol, Richard Theis, and Ian Watts. So for today's session, it's a marathon, 80-minute sessions. We have combined both introduction and deep dive together, so we have lots of time. Please stick around. We can go through the presentation, and then we have time to have some discussions around your questions and whatnot. Agenda, I'll just walk you through the overview of the project. We'll walk you through IBM Cloud. This is an IBM Cloud provider session, so we're going to walk you through the IBM Cloud. Then we're going to have a deep dive around the activities we do. We'll talk about the IBM Cloud Provider. We're going to do the cluster API provider IBM Cloud, and then we're going to have discussions with you. We have some topics in the discussion, but anything from you. All right, so before we go talk about the provider IBM Cloud, let's talk about Cloud Provider SIG. Not sure if you're familiar with the Cloud Provider Special Interest Group, but the SIG was created over a year back, last year, early in the last year. And it was created with a few things in mind. The first one is to ensure that Kubernetes ecosystem evolve in a way that is neutral to all cloud providers, right? So as you know, there are several cloud providers in the Kubernetes areas, and there will be many more, right? Even you think there are a lot of companies moving in-house to their infrastructure using Kubernetes. They are also a part of that journey. And the SIG is also making sure that the Kubernetes ecosystem evolve in a way that provides a consistent, high-quality user experience across the providers. So to achieve this, the Cloud Provider SIG, it defines the cloud provider interface and provides mechanism to initialize a cloud provider implementation. There is a controller for routes and node and for services. So we're going to deep dive on that. So Richard will cover something called CCM, the architecture for this interface. If you're interested, there's a link on github.com, Kubernetes Cloud Provider. You can find tons of information there. So what happened in this area? The Cloud Provider SIG, like I said, it was created with a couple or few different purposes. One of the purpose was to combine different cloud provider SIGs. So until like few months back, we had a special interest group in different cloud providers area. There was like a SIG called SIG AWS. There was a SIG called SIG Azure, a SIG GCP, SIG IBM Cloud, and SIG OpenStack and SIG VMware. So we had different SIGs for these major cloud providers, and like I said, there are many more cloud providers out there. But with this Cloud Provider SIG, the community thought it's a good idea that we bring all these SIGs into like one umbrella, into one cloud, into one SIG, so that there's a better collaboration across the provider members, and we can do our job better, right? So what happened after the last KubeCon? I'm not sure if any of you were at the KubeCon Barcelona, but we had good discussion there. And after that KubeCon, we have created some open documentation. We worked with the steering committee, all the different SIG leads in the cloud provider area. They came to a conclusion that hey, let's just move under the Cloud Provider SIG as a working group, all right, or a sub project. So IBM Cloud Specialist Group, which was called formally, it's now called Provider IBM Cloud. And it's a sub-project or working group of the Cloud Provider SIG. All right? So what we do under this working group or under this sub-project? Like I said, all these Cloud Provider SIGs has the similar purpose of how you can build, deploy, support the Kubernetes on the particular cloud, right? So if you're using IBM public clouds, private cloud, if you are using different cloud providers, right? How do you create your cluster on their infrastructure, right? What are the different ways you can use to leverage the resources particular cloud provider provides? Okay. From IBM side, we have public clouds, we have private clouds. The both are participate in the CNCF certified Kubernetes conformance program. I'm not sure how many of You're familiar, I'm sure, a lot of you. But this both clouds from our side are certified, and there are many others as well. But under this sub-project, it gives you an opportunity to to talk to the IBM team members working in this open space, in the Kubernetes community, right? Many developers and leaders, some of them are here. They regularly attend the SIG meetings or the sub-project meetings. We have some discussions on the Slack channel. We provide updates on the Slack channel for this Provider IBM Cloud. It's on one of the Kubernetes Slack channel. Regularly on the public side, on the private side. Also, you can follow the evaluation, right, of the IBM Cloud platforms with respect to Kubernetes and some of the other CNCF projects. I mean, IBM Clouds, you're leveraging so many projects which are part of the CNCF, Helm and etcd and, many more, right, Prometheus and, So, this platform provides an opportunity to interact with the team that builds and operates IBM Cloud. All right, so how it is created? What's the structure of this subgroup, right? A sub-project. We have 3 co-leads. It's like a fault tolerance system here as well. The odd numbers are good. 3 co-leads, so at least one is around all the time. We have Khalid Ahmed, who unfortunately could not make it to the conference because of the conflict, but he is specialized in the thing called MCM, Multicloud Manager. We have Richard Theis. He represents the IKS, the IBM Cloud Kubernetes Service, and ROCks, the OpenShift side on IBM Cloud Kubernetes Service. And myself, Sahdev Zala, who represents from the open source side. You can learn more about this sub-project in more depth and go through its scope, the governance, whatnot. I have just provided a link, but it's again the github.com, Kubernetes. It's a community repo. So it's still called SIG IBM Cloud there. All others, the previous provider SIGs are still called SIG. But if you check out this link, you will see that a big deprecated sign there. So eventually, the documentation out there for individual providers will move under the Cloud Provider documentation. We have a mailing list, which is called now Kubernetes Provider IBM Cloud. Like, we have made updates as possible on different areas. Everything is updated with this, the change in the structure, right? SIG versus sub-project. So that has been done. And then you can find more about this project again on the, we have good README out there on the GitHub community repo. What do we do? Just high-level the activities. I mean, there are several ways you can communicate with this sub-project of Cloud Provider SIG, and participate, right? We would love to have more people involved, more people contribute to the different parts of the project. So, I mean, like I said, we would love to have you contribute, and we would love to help you out. If you are new contributors, one of the things I do as part of my job is, besides, co-chairing this and other things, being the maintainer, one of the other things I do is participate in the contributor experience special interest group, and we always help new contributors getting on board. So we also have like a SIG meet and greet session on Monday. I don't know if any of you were there, but it's basically having new contributors on board, and these provider SIGs are one of the easier way to get on board, get familiar with the community work, and that kind of stuff. So if you're interested, please reach out afterwards, on Slack or here, right, and we can talk more on that. But we meet every other week on Wednesday at 2 p.m. Eastern Time. All the meetings are recorded, and I have provided a link. They're all on the Kubernetes YouTube play channel there, so you can watch all the previous recordings there to learn more about the past discussions. We have presentation typically on various topics, from both public and private cloud side. We talk about like what's the upgrade strategy from the IBM, right? Kubernetes. We talk about some use case with the users like SIG. We have a couple of folks from SIG. They typically join the call. Like NetApp folks. I was told by folks that they usually like to watch videos later on, so they watch the videos. Slack discussions, like I said, there's a Slack channel called SIG IBM Cloud or Provider IBM Cloud. It's out there. And other thing we do is we provide updates of our activities. So every other week we have a Cloud Provider SIG meetings, right? That's the bigger one, as I mentioned earlier. So all this working group, they represent there. From, like I said, from AWS and from GCP and Azure and OpenStack, and so all these wraps are there. We always attend there. We provide the updates there. We have sub-projects under this working group. The first one is called Cluster API Provider IBM Cloud. This is about the Cluster API project. It basically leverages the Cluster API project, which is on the github.com. It's again a community project, but all other providers, they extend it. So we have the work going on there. Again, if you're interested in contributing, please take a look. Brad will be covering that more. We have IBM Cloud Provider work going on. That's the IBM Cloud Provider that we use at IKS, the Kubernetes service, more on load balancer. And Richard will talk more. He will walk you through about more interesting stuff, the architecture, the cloud controller manager stuff, and other things. One of the things which the Cloud Provider SIG has been focusing for some time is moving the entry. So some of this provider has entry code, which is part of the Kubernetes repo. They're moving it out, so called out of tree, to make it more clean. So that also, Richard will talk a little bit more on that. And then again, as I mentioned, we participate in the SIG Cloud Provider general activities. We participate at the KubeCon and the community meetings and whatnot. So with that, with the basic overview, we're going to talk a little bit on the overview, right? Like I mentioned earlier, we will just provide an overview of IBM Cloud on the Cloud Kubernetes service. We're at OpenShift on IBM Cloud, very exciting things happening there. We have Multicloud Manager. So we have Richard will first walk you through about IKS and ROCs, and then we have Ian. I will walk you through Multicloud Manager, and we'll continue talking, continue discussion. Have any questions, please, feel free to interrupt us. With that, Richard. Thank you.
Thank you, everyone. So yeah, I'll be talking about IKS, or IBM Cloud Kubernetes Service, and then what we call internally ROCs, which is our Red Hat OpenShift on IBM Cloud. So I'll walk you through the services themselves at a high level, and then I want to go into a little more detail on the actual cloud providers and what they provide under these services. And the cloud provider itself does not have to run as part of a managed service. It could be Kubernetes on IBM Cloud. But we'll start with IKS. It's our, if you want to say vanilla Kubernetes service, it's our managed offering where you can create your own Kubernetes clusters. Get your compute hosts, deploy, manage your apps. We participate in the CNCF Kubernetes certification program. So we've been doing that since its inception. We started IKS in the 1.5 Kubernetes release timeframe. And today, our latest version is 1.16. So we've come a long way, and the certification all along the way from, I believe it started in 1.7 timeframe for the certification program to today on 1.16. So as you would expect, we deliver Kubernetes as Kubernetes. It's all the features and functions that you would expect to have from Kubernetes are available. Obviously, there are certain things that are not. On our IKS service, we don't turn on alpha features from Kubernetes. You get beta and GA features, but alpha features in general are not turned on. But otherwise, it's certified And the certification is at the GA level of APIs. That's how Kube does the certification. Only GA APIs get certified through that program. So if you want more information on the service, what it all provides, what you can get with it, I have a link there where you can go check that out. Next thing, which is a pretty important topic if you're using Kubernetes, is currency, keeping up with releases, and so on. Now, I should have an asterisk on this because Kube hasn't released 1.17 yet, so it hasn't had its 4th release of the year. But it'll be coming here. December 9th, I think, is their target. So anyway, IKS, Kubernetes, we've had 4 releases in 2019, assuming we get to that 1.17 release from Kube this year, which we should. And one of the questions you have to ask yourself, are you staying current? And this is a topic that goes well beyond IBM Cloud, Kubernetes Service. Any cloud provider has similar discussions. There was one yesterday from Google talking about update strategies. It was a really good talk. If you haven't had a chance, I'd encourage you to go check that out. But it comes down to the question is, does Kubernetes need a long-term support strategy for its releases? And I laid out here, it might be a little bit hard to see, but if you download the slides, a little bit easier. At the bottom of the slide is IBM Kubernetes Services versions, when they were released, and when they will become unsupported. So starting at the bottom of the slide is 1.12 release. It came out in November of last year, and it was unsupported as of November of this year, so November 3rd. And then next is 1.13. It's marked as deprecated right now. It will be unsupported in February of 2020, and then going up from there, 14, 15, and 16 are all supported. And the timeline for each of those is along that same line, 1 year. Now, if you look at Kubernetes itself, Kubernetes supports 14, 15, and 16 as their release. They're under development right now in 17. And when 17 comes out, they may give you some patches for 1.14 release for a very short period of time, but then it'll be unsupported. So effectively, you have 9 months of support once a release becomes available from Kubernetes. And for most folks, that's just way too fast. So that's where this question comes from a lot of community members, is what to do next. Well, I've included a link here. This is a recent update to the community on the working group that they've established for the LTS to say, what does Kubernetes look like in the future with respect to support? So you'll find that whether you look at IBM Cloud or you look at Google or others, you'll have a similar structure and release support from these other cloud providers as well, because there's not many folks that want to maintain multiple releases that Kubernetes is not going to maintain themselves. So generally, you have this same model where you get the latest releases, but you'll have some deprecated releases and then eventually unsupported. So with that, the community is considering supporting 4 releases of Kubernetes at a given time. So that would give you a 1-year support window, which would potentially extend, our support window then. Instead of having 1.13 be deprecated, we potentially could support that much longer. So a lot of good questions there. And then on that, you'll find that there's some building blocks the community needs to establish before they could consider even a long-term support. So if you have interest as a user, operator of your cluster, please watch that discussion and contribute if you believe you could help out in those discussions. So then let's jump over to Red Hat OpenShift. So we just came out with it in August, Red Hat OpenShift on IBM Cloud. It's a managed service as well. Similar in structure to our Kubernetes service. We manage the control planes or the master. So that'd be your API, scheduler, controller, manager, and cloud provider at that level. And then you pick your worker flavors, and we deploy some critical components. You get what OpenShift gives you, and then from there you deploy your apps. So you take a step forward on OpenShift from Kubernetes, you get all kinds of enhancements from that level to help you modernize and deploy your applications and manage them. So a lot of tooling from Red Hat to do that. We have a lot of details on our docs if you want more information on how that all works, right there in the link in the slide. We currently support the 3.11 release of Red Hat OpenShift. It is based on Kube 111. So there's little asterisks there, like Kubernetes doesn't support 111 anymore, but Red Hat does, okay? And it's their version updated with patches, security fixes, so that's all still happening. So even though it is based on Kube 111, don't let that scare you. It's getting all the security and update fixes that you need. We don't have a tentative on a supported date yet. This is our initial release. All right, so that's the managed service side of things. So I want to jump over to the cloud provider side of things. And I'll call this our IBM Cloud Provider KCM architecture. And it actually applies to any cloud provider. And this is from the Kubernetes documentation. So you can go out and check that out there. And it'll walk you through in a little more detail if you want to come back and refer to it later on what this all means. But this is a Kubernetes cluster architecture on top of a cloud. Without the Cloud Controller Manager. And if you look at the various components at the top left is the Kube Controller Manager. And it has a little arrow there that is a cloud connector, we'll call it. And then API server is next. And at the bottom right are the kubelets talking to the cloud. So all these have connection points into the cloud. That's how Kube worked from its early days. And that's where was mentioned that Kubernetes has all this code from cloud providers in core Kubernetes. And that's not ideal. Obviously, if you look, IBM's not there. And the reason IBM's not there is because when we started our journey on the Kubernetes service, they were not accepting new cloud providers into the code base because they knew that the explosion that was going to happen, they didn't want to maintain everybody's cloud in Kubernetes core. So that was going to be a problem. So we needed to change this architecture. But getting there is not easy. So we need to disconnect these connectors in each of these core components of Kubernetes so that the cloud connections can be done in a more pluggable fashion. And so that's what our journey is about in the cloud provider, and a lot of the discussions are about within our SIG, and especially the SIG cloud provider umbrella, is how do we go from here to here? This is the end game that we want to achieve. So the end game is each of those core components of Kubernetes, the controller, the API server, the kubelet, they no longer have cloud connectors. They don't want to talk to nor need to talk to the cloud. All they need to know is that there is a cloud provider. It's external somewhere, and it will handle the core actions that need to happen on the cloud. And that external cloud provider is the Cloud Controller Manager. So the community wants to provide a reference implementation for this from which cloud providers can build their own Cloud Controller Manager. And as you would expect, there's Google and Amazon, IBM, others doing this. You can even, we had a SIG a deep dive yesterday, and someone was asking about building a cloud provider for their private cloud, right? So there's nothing that would say you couldn't do this yourself for your cloud. The goal is to get to that end game. And for most folks that start fresh, it's easier. If you're in the area of extracting and migrating, it's going to be a little bit more difficult. So what are the, let's go a little bit deeper now into the interfaces. So what is a cloud provider? What does a Cloud Controller Manager do under either architecture? There's a common interface that you implement, and you can implement various aspects of it. You don't have to implement it all. I'm going to highlight what IBM implements in our cloud provider, what it provides on each of those interfaces, and what it doesn't need to do, and why it doesn't need to do it. So at first is one of the biggest things a cloud provider gives you is a load balancer. So each cloud has their own cloud load balancer, and the integration point is through the service controller in Kubernetes to say, hey, if I create a load balancer service, Kubernetes will set up a lot of the components like the cluster, IP, the node ports, all of that, routing in internally through kube proxy, but ultimately you need a load balancer created, and that's done on behalf of the cloud provider. So we have, in IBM Cloud, we have 3 versions of our load balancer service. In the early days, on our classic infrastructure, we had a network load balancer that ran within the cluster. It was based on IP tables with virtual IP managed within the cluster through Keep Alive D. We've extended that to a network load balancer version 2, which is in beta, is our IPVS-based load balancer. It also runs for, on the classic infrastructure. And then lastly, on our VPC infrastructure, we have a new VPC Layer 7 load balancer that we've recently integrated into our cloud provider. So load balancers are critical for most applications, as is obviously nodes. Instances is what the interface is in Kubernetes. So Kube needs to know what information about the node, such as, hey, where is this node? What zone is it in? What's its IP? Different aspects of the node. So Kubernetes can do things that are really critical, like, hey, scheduling across zones, for example. And that's where also the zone interface comes in. So we rely through the cloud provider on our bootstrap process to set up the node from which the cloud provider can extract the data and give that to Kubernetes to finish the bootstrap process of a node. And now we recently enhanced our cloud provider, so obviously we can get from the KCM to the CCM architecture through those two interfaces. And then a couple more. Not a lot there because we don't implement them. But other providers do. So clusters and routes in particular, we don't implement because we use Calico in our managed services today for routing on the overlay over the infrastructure. So we don't implement that. Other cloud providers do. But as I said, each cloud provider can choose which interfaces they want to implement. And you really, you don't even have to implement the load balancer interface if it's not applicable to your environment. All right, so next steps, migrating. So because we're not in Kube core base, we don't have to extract anything. Other cloud providers do, but we do need to migrate. Now, if you're running ROCs, the Red Hat OpenShift clusters, they already have migrated and they're using the CCM today, so no action required. That's already ready to go. For our IKS clusters, we need to do the migration from KCM to CCM, and we're hoping to do that soon. Time frame in 1.17 is hopefully, if we can achieve that, that's when we'd like to do the migration. There are some challenges with that. If you're interested in our status, we keep it posted here on this spreadsheet. This is not just IBM Cloud status, it's all cloud providers. They have updated the tracking sheet to say where they're at on their migrations to the new architecture. So some folks, some cloud providers have a lot more work to do. They were a lot more ingrained in Kubernetes, so the challenges are a little more significant. But one of the biggest challenges for anybody that's making this migration, and our goal is to make it seamless. Like most folks that use any of these services shouldn't care that, hey, it's got this KCM cloud provider versus CCM, but is locking. Locking is one of the key issues for HA. So Kubernetes runs multiple controllers that manage certain resources. Service controller, for example, manages load balancers. And you only want one service controller running at a given time. And they do that through leader election locking and etcd. And we want to make sure that when you migrate from one to the other, that you don't get a service controller on the KCM and the CCM running in your HA environment trying to create or delete load balancers at the same time. So that would be a problem. So the community is working on a solution for this to maintain availability, yet control the locking so that only one controller in each of the architectures is running at a given time so that you can ensure that migration is smooth. The alternative is a little bit of downtime, taking the controllers down to not have a leader on the service controller, bringing it up on the new architecture, and so on. So that's a big area the community is interested in achieving to make this final migration happen. So what's the future hold for the IBM Cloud Provider work? Well, we're going to continue on this migration strategy to the CCM, working with the community where we need to help that happen. And the community's been really good about it because they realize that there's a lot of folks already out there having a lot of clusters. They need to do this right. And so they've taken very good care to help ensure that all cloud providers are able to move forward on this path together and not leave anybody behind. So that's been really helpful for us. And like I said, right now our cloud providers just used in IKS and ROCs. And Would love to hear if folks have interest in building their own Kubernetes clusters on IBM Cloud. And in that case, would you be interested in the IBM Cloud Provider and in using that? Of course, that would mean we'd need to open source that. So that's one area that we're looking at. With that, if we do open source, we need to do the improved documentation for usability. The next area that we're looking at is, and this is a community initiative as well, is integrating Cloud Provider testing with the overall CI/CD testing for Kubernetes. So Kube comes out with, say, 1.17. They're working on, say, release candidate 1, and they want to know what does this release candidate look like if I run it on Google or Amazon, IBM, whoever, right? Is it still good quality, or are we seeing some significant failure rates across the cloud providers? So then you might have to step back and say, what changed here? So that's an area of ongoing concern and an area for improvement. And we'd like to not only just submit our results through the certification program, but also into the general test framework of Kubernetes that we can say, hey, look, 1.17 looks good for IBM Cloud, right? Or this patch release 1.16.5 when it comes out looks good too. And then lastly is container image security is another important topic. If you look back at the various components Kubernetes has provided as part of the release artifacts, some of the images have a lot of CVEs, and that's based upon the distributions they're based on top of, additional add-ons that are installed. And so we're always looking to streamline our container images that we provide through whether it be our CCM ourselves for the cloud provider or things that are provided by the community, say Hyperkube, which they are now moving away from, to API, Kube Controller Manager, Scheduler images as well. So that's an important topic. All right, with that, that should cover the cloud provider, and I can take any questions now, or we can do that later as well. And I'll turn it over then to Ian. Thank you. Oh, sure.
What is KCM?
So the question is what?
What was KCM?
KCM. So the question was, what is KCM? KCM. That's the Kube Controller Manager. Kube Controller Manager. And I use it in a kind of a loose term on those slides back there. IBM Cloud Provider KCM. I call it the KCM architecture, which is really to say that the cloud provider is built into the KCM itself to provide controller services through that. So that's what that is. And then the CCM is the Cloud Controller Manager. Yep. Yep. Anything else?
Sure. The speaker yesterday said that Kubernetes is not highly available. How vigorously would you argue?
Oh, I would say that, well, so the question was, a speaker yesterday would say Kubernetes is not highly available. I'm curious to know what aspect that they were referring to. Was it control plane, data plane, applications, and so on, right? There's a lot of aspects to HA there.
Yeah, I think it was the infrastructure in terms of nodes somewhere down at that level more than the application layer.
Okay, so focusing more on the node HA, or okay, infrastructure layer. So I think one of the challenges you got to think of, Kubernetes is got a really nice architecture in the sense that they have state that they store in etcd, and they want to achieve that state. And the controllers keep working to achieve the state, right? The idea is that things will fail, and that you need to be able to recover from those failures. So if you use the tools that Kubernetes provides, you can help mitigate failure and thus achieve the HA you want if you use the tools right. So there is a challenge involved to using them right. So if I have a deployment, one replica on one node, and that node goes down, yes, HA is not good. But if you can say, I want 3 replicas, I want to spread them across zones, and if one zone goes down, then my application is still serving in the other zones. And you put that behind a load balancer, and using Kubernetes probes on pods, liveness, readiness, you can start to achieve the HA you need to. So I'll say from IBM's perspective, using the tools that Kube has, if you use them right, you can get very good HA through Kubernetes.
So
Yeah.
it's like the speaker mentioned about security. You can get it, but you don't
Yes, so that question was, the speaker mentioned, sorry, I should get you the mic here, that you can get security but not for free, basically, yep. So yeah, totally, and that's it. You can't, the tools are there, you need to use them, and if you use them right, you can make it work, yeah. Here, one more? Yeah, might as well, yeah, that might help. They like to hear it on the video, then they know.
Yeah. Just a quick question on ROCs. Now that IBM's acquired Red Hat, like how closely do you work with like Red Hat's teams on this? Is it more like an arm's length sort of partnership, just like if I was doing OpenShift on AWS, or is it more like closely integrated? Like what's that look like?
Sure. Well, if you look at the time when we released ROCs, which is August 1st, and you think back, we did development before that. That was before the whole thing can really close and all that. So we couldn't work together, closely on that. Future roadmap. So the question is, what does the future hold? Working together, certainly, yes. I mean, we want to work with Red Hat to. Go ahead.
You mind if I take that?
No, go ahead.
Yeah. In many ways, view Red Hat and IBM as a partnership, okay? Because it's very important to IBM that Red Hat OpenShift runs just fine on all the platforms.
Yep.
So I just want to be very clear. Do we work with them? We work with them just like they would work with any other partner. But if you go talk to Red Hat, there's a lot of autonomy there. There's a lot of freedom there. And I think the best way to view it is as a partnership. We obviously want OpenShift to run as best we can on IBM Cloud, and we're going to ask some questions like any other cloud provider would. But I do think it's worth folks understanding that when you go see what Red Hat does, their stuff's going to run on all the clouds just like it always did.
Right, exactly. So that's how we approach it today, right?
So a follow-up on that, I wanted to ask, a Red Hat guy talked to me yesterday, he said, of course IBM is saying you should use OpenShift, and I said, well, what's OpenShift? They've never discussed it with me. I guess that's a totally separate offering that we can choose that we just haven't chosen to look at. So yeah, I was just wondering, what's the urgency? Is that something we should move to, or can we be perfectly happy never knowing about it?
Sure. We'll let Brad.
So the really nice thing about OpenShift is a couple things. It's really focused on easing the pain in certain areas. One of the areas where OpenShift does a really great job is what it calls source to image. So it can pull content from the GitHub repositories and build the images for you, take care of all that pain and the YAML deployments. So a lot of that painful piece that if you're not really experienced in building those Docker files and YAML files, it's going to take care of that. The other nice thing that OpenShift is going to do is it's a little bit opinionated. It's going to make some decisions for you on how the networking should be and provide configurations for the networking for you out of the box. So, and it's going to also provide you some good opinions on how to do your continuous integration, continuous deployment. So the best way to think of OpenShift is it's Kubernetes underneath, but then making some opinionated choices and decisions about how to do some of the pieces that you may not want to deal with if you just want to go develop your app. But that's the best way to look at OpenShift.
Yeah, exactly. And so it comes down to where are you at in that journey, right? I mean, do you want that help? Or are you like, oh no, I need to be the latest and greatest Kubernetes, I need that feature and I want to build my own, right? You know, that's.
You've already done it the hard way.
Yeah. So, sure. Anything else? All right. All right, turn it back over. That's right. For real this time, yeah. For real.
All right, everybody. Thanks. So I'm going to talk to you just a little bit now, switch topics just a hair, and just going to do something quick. It's not a huge crowd today, but I do want to kind of see what the outlook for your companies are as far as number of clouds that you will deploy to or number of clusters that you may have. So hands up in the crowd, who has at least one cluster in their business today. Like that should be everybody, right? Yeah. How about 2? Yeah. How about multiple providers? So meaning local or on a cloud. Okay. All right. So at least 1. That's good. All right. So what I'm going to talk to you today about is a new product that IBM has announced. It was out the start of this year. In I think it was September. It was released on top of OpenShift. That is the new platform of choice. It runs on IBM Cloud. It also runs privately. The product itself, though, is meant to help you manage multiple clusters. So the idea that you could have in your environment many different types of clusters and used for different things is kind of the key to this product here. And so you may ask yourself, well, why would I want to run multiple clusters and care about them and manage them? And so some of the things to consider when you start to develop more and more of your business applications on Kubernetes is, you may have laws you have to apply to for where your data may be, right? So some of that may be like I have to have my data within the country, or maybe it has to be on premise, or I have to have it at least in 2 geos. Like I know certain banks and stuff have to have certain rules where data is replicated across 2 different geographies. So those are things where you may consider, I may need to have a separate cluster in different locations, right? And then manage the information back and forth. The second piece is, okay, now I've got my sensitive data covered. What about my very expensive, large amounts of data that is not private, right? And I'm spending a huge amount of money running that locally in my environment, buying storage racks and whatever. I don't need to do that. So the answer is you can run some of that in cloud services, and those cloud services will generally be cheaper than local. We're not going to be opinionated on which one you use. You can negotiate your own deals. IBM would like to sell you that, but there are other companies out there that'll do that. And the point is, MCM will help you kind of manage all those clusters across that environment. So a third reason would be services. So as you start to build your applications, you may be looking to, say, use some analytics, say Watson Analytics, or maybe you're after Google's AI, or some object storage in Amazon. Just because your app developers are going to be out there building cool stuff, and they're going to want to use the latest and greatest stuff. And if you tell them it's in one cloud, they're going to get really angry and get frustrated, right? So they're going to want to be able to run stuff where they need to run it, and with the services that are available today. And of course, the last one is kind of a disaster recovery resiliency kind of story, and that kind of plays well into, you may not be in more than one provider, but perhaps in different regions. So you could have, with an LA and then maybe another one in Texas, so that if tornado hits or you get an earthquake, you don't have a problem with data loss, okay? And so those are some of the reasons why you would want to have clusters spread across geographies, or maybe even just, maybe not geographies, maybe they're close together, but they're offering different services, okay? So what does Multicloud Manager do when you got that case? So it does a couple of things. So first off, you can see in that little picture there's kind of an overview of your cluster information. You can kind of start to see where you have capacity. You can see where your compliance is set to. And in order to do that, of course, you have to configure policies. You can say, so in the bottom, in the kind of the middle there, in the blacks, I don't know if you can read it very well, but that's an example of a YAML where you can configure a policy where you can set the container size to not grow past a certain memory allocation, right? And then, of course, there's like a little diagram here right next to that one in the bottom corner. That is a part of the app model. So inside of MCM, they're attempting to pull together what they call an app model. And I have another slide on this in a second so we can get really deep into it. But the idea of it is to pull together your clusters and your Helm charts and all the other pieces into some sort of a view that helps you represent the actual application that you're managing, right? And so one of the things that will end up happening over time is you may have a cluster that's local running your data and your database access, and perhaps it has a WebSphere MQ or a Liberty server running to host back-end processes. And then you have perhaps out in the wild west of the cloud, you have app servers and other things and load balancers and stuff like that running your web mobile business, and you have data transferring between the two. And so in the diagram here, I don't know if you can see it, there's kind of, in this example, they have this application running across 4 different clusters, and 2 of those being cloud, okay? So those are kind of some of the tools that help you kind of manage that environment as it gets more and more complex, because you're going to get past that point where it's, hey, I'm just going to log into that cluster and see what's going on. I mean, you know, if your application team comes to you and says, I have a problem, you're not going to know where to go, right? The application's now running in 5 different clusters, and what's going on? Is it, you know, a node problem? Is there an application problem? Do you have networking issues? Those are all problems that you need to have some sort of a tool to help you resolve. All right. And so this last chart here, I think this is where Khalid was asking for your help. So what's going on is we're building this application model that I described earlier. So you guys are probably familiar with Helm charts, right? So there's a Helm chart there, and we've added an app YAML and an operator YAML as a part of it. Now what happens is inside the app YAML, it kind of configures all the pieces and the policies that are a part of it. And then the second thing that it does is it sets up subscriptions. So this is a new idea that we've kind of pushed, and it's now open source. So we're asking people to contribute. And so the links are below here. So there's the operator subscription, and the operator is deployable. So what happens is when you deploy your application, it registers with the subscription, and there's a channel that is constantly watching for changes in those subscription pieces. So for example, maybe you have a subscription to a load balancer, a certain type of load balancer that's running, and your subscription may say, with point releases, I want updates, right? And so what should happen is you have a periodic check on at your pod level. It will continually run using the operator model and checking to see if there's updates. Now, when there's updates running, if you have in your app model to decide you want automatic updates, it would do a rolling update using the operator path and actually update your system, keeping it live and running, and getting the latest frequency updates. Now, that's, again, subscription-based, so you can control whether it happens or not. You can also control whether it's automatic, or it lets you know in the MCM that there's something to be done, and then you can trigger it to change. Okay? Are there any questions about that, or anything about MCM in general? I can kind of take, because that's kind of the last of those slides. No? Okay. Thanks for your time. Todd?
Okay, so one of the things we look at is hybrid multi-cloud, and looking at a strategy of Kubernetes running everywhere, OpenShift running everywhere. So we'll look at how we're going to support that. There is a Kubernetes SIG for clusters and a cluster API, and the different providers need to provide their sort of cluster API provider. It's an interesting model, the cluster API. If you're not familiar with it, it's open source. But basically what happens is you have a little bootstrap cluster, and from that bootstrap cluster, you use that to actually get your actual real target cluster up and running wherever it may be. And in our case, it's on IBM Cloud. And they have, just like you have kube control, they've got cluster control, so they've got commands. And there's different providers. All the different providers provide their implementation of the cluster. IBM provides it, and we have several folks who are contributing to the open source project in Kubernetes for the cluster API. So that work continues to go on, and we continue to focus on it for multi-cloud, right? So multi-cloud, and if you're able to do it through the cluster API, that's the way to do it. I don't want to go into too much detail there, but it's sort of a piece of community that if you want to take a look and see the work that we're doing there, Guanya Liu is one of our leads who makes a large number of contributions to this project, and several folks on his team do as well. So just a little piece of what's going on there for hybrid cloud and cluster. And now I'm going to change gears a little bit and talk about some other open source projects that IBM Cloud is really interested in. So Kubernetes is great, cloud native computing is great, but if you look out there, it can get a little complicated. Now, that's what this chart. So if you want to do cloud native right, you really need to understand the concepts of 12-factor applications, understand microservices, understand all the different projects that are available in the Cloud Native Computing Foundation. There's different choices, different options. And some of us really enjoy this, right? This is our world and we live in it and we really enjoy it. But again, you know, put yourself in the shoes of a Java or J2E developer who wants to get all the benefits of cloud native, but maybe they just really want to write their Java applications and really, maybe they're, you know, it's nothing wrong. Maybe they're just not quite as interested in all the nuances and details of cloud native like some of us are. It could happen, right? So, you know, the goals and the challenges we have is how do we make those people happy? Because how many Java application developers there are out in the world? A lot. So what are we doing? We've put together some open source projects that are really tailored towards helping to bring the benefits of cloud native to folks who work in, say, Java or Python or Quarkus or Node, different areas where it's pretty straightforward. The person really wants to worry about their code and get the benefits of cloud native, and how can they do that as painless as possible. And so one of the projects we have is Kabanero, and it's got a lot of associated projects with it. We'll kind of talk about what they do, but it's going to provide some cloud native frameworks, integrated development tools, automated DevOps tools, give you some options to help you modernize your applications and move them to a cloud native environment. And this is all built on standard best practices for running in cloud native environments. And so one of the ones we really like to talk about is Apsity. So what Apsity does is out of the box, it's going to provide you different runtimes. It'll provide you a WebSphere Liberty runtime. It'll provide you a Python runtime. It'll provide you a Node runtime. It'll provide you a Quarkus runtime. And so it'll provide you all these different runtime stacks so that in your enterprise, you don't have everybody building their own Java container stack, right? You know, hopefully you can get agreement and consensus, and there's, you know, your architects who can decide, hey, if you're going to use Python, here's the runtime stack you should use. If you're going to run Java, here's the stack you should use. If you're going to use Node, here's the stack. So at least some way to get some sanity and consistency across your enterprise is the idea. And so Apsity it's built on operators, so it's using best practices for, you know, lifecycle management in Kubernetes. And with this, people can really easily get up and running on those stacks. And other parts of what was on just the previous chart, we've got integrated development tools. There's a project called CodeWind. It has plugins for both Eclipse and Visual Studio Code. So in your favorite development environments, you've got the ability to start getting some cloud native help to build those applications, get them turned into images and deployed out on your favorite infrastructure, Kubernetes, OpenShift, what have you. The other thing we've been focused on at IBM for the past 18 months is getting all of our middleware to be cloud native. So we have taken responsibility for saying, if you look at all the enterprise customers out there, they're using lots of enterprise software, DB2, MQ, WebSphere Liberty, for example. And if you look at what we approximate is about 20% of that software out there has been able to make it to cloud native, but there's that 80% kind of lagging behind. There's a lot there. And so our goal over the past 18 months was to get all of our software cloud native and ready to run on the cloud. And so we've done this, and we call these cloud packs. They're IBM certified, run anywhere. They're going to run on all the different clouds, run on OpenShift, and OpenShift runs on all the clouds. So you can feel very comfortable that we're getting all of our middleware so that it runs anywhere. And that's why we don't necessarily care where you run it, because we're going to make sure it runs everywhere and run on top of OpenShift. And so we've got several examples of these. The Cloud Pak for applications, the big piece that you'll find in there is the WebSphere Liberty. So if you're wanting to build J2E applications, Java, all of that's in the Cloud Pak for applications. Cloud Pak for data, you can think more like your DB2 and other databases and database-related type stuff. Cloud Pak for integration is going to be more like your MQ family of middleware. And then we've got a Cloud Pak for multi-cloud management. So we're also making sure we've got pieces to worry about running multi-cloud. And people say, well, why multi-cloud, right? Well, we've seen these stories before. Think insurance companies. You've got one insurance company, it's using one cloud, it's got a lot invested in it, and what happens? Another insurance company buys that insurance company, and maybe they were using a different cloud. So whether you like it or not, sometimes because of how the world works, you can end up using multiple clouds. And so, we worry about providing offerings for our enterprise customers so that they can deal with those types of situations. Sometimes you may have customers that want to use multiple clouds, just like in the old days where they would sometimes have half Oracle databases and some DB2 databases, because the enterprise could then have a little bit of leverage. Hey, I could go either way. I could use this database, I could use that database. Same thing with clouds. So, we have an opportunity to see multi-cloud opportunities, and we're investing in there as well. So at this point, we've covered a lot of stuff, and so I'm going to open this up for discussion. And any questions on anything? We've got several folks smarter than me that we can force them to answer those questions. Okay. Well, then you get to go. Mm-hmm.
Nobody's mentioned Cloud Foundry in this presentation, and I'm just kind of curious, where does that fit in the picture here, and how it gets managed into the future?
That's a great question.
Brad, could you repeat the question?
What's that? Yeah, do you want to give him a... Do you want me to repeat it? So the question really was about Cloud Foundry and how does that fit into this world. We haven't really mentioned it. Cloud Foundry is something that we offer in the IBM Cloud. There's a Cloud Foundry service. We've done a lot of really cool things with it. And what we've been looking at in what we offer is how we can provide cloud environments that allow you to use all your Cloud Foundry stuff when you want to use it, and how you can also use the non-Cloud Foundry stuff if you build some new stuff on Kubernetes. So there's actually a project in a SIG group in Kubernetes called Service Catalog. And what SIG Service Catalog does is it's got what's called a service broker. And so it's got the piece inside of it, and Jonathan Burkon is the chair of it from IBM. But what it worries about is how do you pull in all those Cloud Foundry services into your new cloud native world? So, the point of view from IBM is, hey, our clouds are going to support both Cloud Foundry and cloud native stuff. We don't care which way you go, because any of it you go, we're going to make money because it's all utilization, right? So we do a very good job of supporting Service Catalog and the techniques that are out there. Now there's going to be some more advanced techniques I think you'll see coming down the pipe with operators that will also worry about supporting Cloud Foundry services as well. But there's definitely effort there to make sure that the Cloud Foundry stuff certainly at least in IBM Cloud, is something that you can continue to use and use alongside with everything else. And then the way to pull it into the Kubernetes Cloud Native apps is through the service catalog. So, you can use it the way it is and then use it pulling it into your new stuff. Does that sort of help? Okay, do you have any other questions?
Sure.
Yeah.
And this is probably one that has a bigger answer.
Mm-hmm.
I've asked a few IBM people, is it crazy to containerize WebSphere? Some of our internal experts says, oh my God, that's terrible, never do that. We went to IBM and I think they say, oh, we're going to make money if you do that. So yeah, do that. So I'm just seeking some more opinions. We're planning to go to production with a very large WebSphere container. It takes 2 minutes to start.
Mm-hmm.
Apparently not a cloud native thing to do, but people are just passionately arguing with me saying, these are all things that you should be able to do, you won't be able to do with that, but they're not looking at where we're coming from and how it's improving upon our current situation. So no one's talked me out of it yet.
Okay.
Just get your perspective, is it a good thing to do to run a big monolithic WebSphere application in Kubernetes?
Well, and now do you use WebSphere Liberty or just big WebSphere?
I think the answer is big WebSphere.
Okay.
Liberty is a future project where we're going to migrate out of WebSphere.
So the answer is that's the reason we have those cloud packs, is to enable that WebSphere. So I actually, a few years ago, led a team that worried about both WebSphere and DB2 and how we could containerize them. And early on there were a few problems, and particularly for DB2, we needed some kernel patches and what have you. But ideally, if you want to look at using the Cloud Pack version, that's what it's there for, and they'll have WebSphere and WebSphere Liberty for you, and that should be fine.
And we found a container, I think it came from IBM, where WebSphere was already installed and configured. We
Right.
didn't have to worry about a license. We had it running in less than a week in Docker. It was amazing.
Yeah, that's what we want you to keep doing. So our answer is yes, and we're going to provide a lot of stuff to help you do it, because that's what we want to do. We want to get all those applications running. Because once you get it to the cloud native and running the containers, now I can start talking to you about 12-factor apps. I don't know if you're familiar with 12-factor apps. A lot of great principles for how you scale things up, how if things crash, they'll restart. All these great ways to write robust, very scalable web or cloud applications. And once we get you that first step, right, then we can take you to the next journey, which is, let me show you how you got multiple copies of this running. Let me show you how you can scale this up. Let me show you how, if some of them crash, we'll start new ones up for you. So you'll end up getting a lot of benefits once you've been willing to take that leap of faith and get it to the containers. One of the best demos I gave at O'Reilly Software Architects Conference is, we typically show the benefits of running cloud native, where, oh, look, we can scale it up, we can crash a few things, and I start with a pure cloud native application that's all brand new, and it was it had a little language bot to do some voice stuff. It's all fancy stuff. But really what the audience wanted to hear is, well, what about my middleware? And then in the middle of the demo, I go, well, let's go do this now with MQ, because we had MQ already containerized. And now you got to see the same thing, but now it's with MQ nodes up and running, and then when they crash, being restarted, and using it used like stateful sets and what have you in Kubernetes. So that's really the beauty of this, is it's not just for the new stuff that you get all the cloud native benefits. Work with the IBM folks with cloud packs for the different cloud packs, and let's get the old stuff running in the new world as well.
Yeah, we're working to make this work in multiple pods with Affinity, and the next step, I'm very curious about this multi-cloud thing, because we're doing the work right now to make it work across 2 different IBM data centers, which is a second layer of Affinity that we have to do.
Okay.
But we're making this thing enterprise ready, and it's a critical application that has to work once we go live with it.
Okay, fantastic. Did you stop by the booth yesterday and get a book, or the other day? You got a book, right? Fantastic. So say you asked enough questions, I had one in my backpack. You were getting a free book, but you already got one. Excellent. Did you want to worry more about the questions you had, or we covered them?
I think. So, I honestly, I was answering my team with a question they had. But you were talking about multi-cloud management and worrying about running your application across 2 different clusters and all that kind of concern. Is that right? Yeah. So I think it's actually best practice, I'll be honest with you. I mean, if you were back in the data center days, running your WebSphere servers, you know, if you were a bank or something, you would have your applications running in 2 different zones and doing backups and stuff like that, right? That is what you would do.
Multiple zones and multiple data centers.
Exactly.
Parity with what we're coming from.
Right.
It's got to be better.
Correct, yeah.
Parity.
Yeah.
Otherwise, it's a no-go.
Correct, right. And so, you know, by having, you know, you don't need to have multiple providers, because you can do local, or you can do, you know, IBM Cloud or Amazon Cloud zones, right? So like regions within, so like Amazon, like California and Austin, right, which is one of the customers I work with, does that. And so one of the things to watch for is making sure you have good data pipes between, you know, you're going to pay for that in a cloud service, but that's very, very important, because you're going to want replication at high speeds and things like that, right? The MCM product that I touched on earlier might be very useful for you if you can build an app model on the top layer to see your apps across the different clusters that you, like your different WebSphere clusters you have deployed. It may help you kind of understand if you're within policy even. So like some of those policies can be very specific, like nodes are not going above certain memory thresholds, you're not having restarts, you're not, so like those policies can be like security, they can be how well your application is running and things like that, right? So managing policies, if you're playing in Kubernetes and you're trying to do production, is very important. It'll help you stay compliant, and I know you're gonna have like PCI compliance, and you're gonna have GDPR and all these other concerns, right? And those are valid concerns, and those are things you can use policies to help you set, as well as just the, you know, is my application running healthily, right? So those are some of the other things I would say is as you start to do these like multi-cloud or even just multi-site situations, those are things I would worry about. And of course, like we offer a lot of tools to help with that, and I can talk with you a lot more about it, and there's even a presentation later at our booth where it might go over some more of that as well. Yep.
Anything else?
Any other questions?
We done?
If no more questions, yeah, we are done. I mean, thank you so much, everyone. You know, we utilize more than an hour of our 80-minute marathon, you know, so thanks for sticking around.
Yeah,
Lots
we
of good
appreciate it.
questions, yeah, great interactions, and we look forward to collaborate with you more, you know, like I said, join us on the Slack channel we have for this sub-project, the Cloud Provider SIG, mailing list, you know, whatnot, right? Just let's keep in touch, and we'll talk more as we go further. Thank you so much, everyone.
Thank you.